Command injection is an attack in which the goal is execution of arbitrary commands on the host operating system via a vulnerable application. Command injection attacks are possible when an application passes unsafe user-supplied data, forms, cookies, HTTP headers, etc. to a system shell. In this attack, the attacker-supplied operating system commands are usually executed with the privileges of the vulnerable application. Command injection attacks are possible largely due to insufficient input validation. Methods for command injection. A command injection attack can happen due to various types of vulnerabilities. Here are some common ones. Times arbitrary command injections. Applications that allow a malicious user to run arbitrary commands can be attacked in this way. Times insecure deserialization. Executing deserialization without performing proper input validation can lead to command injections. Times XML external entity injection. XXE if an application uses an XML parser that hasn't been configured properly to parse user XML input. This can lead to denial of service, DOS, attacks, server-side request forgery, SSRF, and breaches to vulnerable data. Times arbitrary file inclusion upload. Applications that allow users to upload files with arbitrary files extensions can be vulnerable to command injections through malicious commands when inserting into the web root. Times server-side template injection. SSTI applications that use server-side templates to generate dynamic HTML responses may be vulnerable to the insertion of harmful server-side templates if unsafe user-supplied data is included in a template. Blind command injection versus active command injection. Blind command injection occurs when the system command made to the server does not return the response to the user in the HTML document. Active command injection will return the response to the user. It can be made visible through several HTML elements. These three PHP functions, if not used safely, can lead to the presence of this vulnerability. In pseudocode, the above snippet is doing the following. Step 1. Checking if the parameter file name is set. Step 2. If it is, then the variable $file gets what was passed into the input field. Step 3. As this accepting input, we can append the command if this is vulnerable to command injection. Let's look at second example command injection with pass-through function code review. In pseudocode, the above snippet is doing the following. 1. Checking if the parameter command string is set. 2. If it is, then the variable $command_string gets what was passed into the input field. 3. The program then goes into a try block to execute the function pass-through $command_string. You can read the docs on pass-through on PHP's website, but in general, it is executing what gets entered into the input then passing the output directly back to the browser. 4. If the try does not succeed, output the error to page. Generally this won't output anything because you can't output stder, but PHP doesn't let you have a try without a catch. Now we will look another last example command injection with executive function code review. Here the command is being created from two sources, a fixed string, ls and a URL parameter, $get modifiers. This means that the actual command that's about to be executed depends on user input. Let's say someone issues a request such as http://main.com modifiers is equal to L. When the code gets executed, the value of $get modifiers will be L, which will result in the command lsl. There is not issue with proper supplied input. If we append the resulting command would be lsl rm*rf, and if application accepts the request then it will cause serious damage to the application. We'll try to navigate vulnerable web application to test one of command injection type and check what an attacker can do if application is vulnerable. We will try to leverage application functionality and exploit the functionality for displaying sensitive information. Thanks for watching.